Today we will discuss engineering problem on the bisection method to solve the problem of a particle moving on a smooth inclined plane. The problem is shown on the screen. The rate of change of the angle theta with respect to the time is given by omega or w smaller than 0. At the end of the t seconds, the equation of the particle is given as shown, and the parameter values are also given here. G equals 32.17 feet per second square, and the displacement x is 1.7 feet in 1 second. So we need to find the rate of change w or omega within error 10.-5. So if we substitute in this equation as t equal 1, we have x of 1 equals minus g over 2 w squared e power w minus e power minus w, because t equal 1 over 2. This is the sign of w. So the rational form is reduced to sin w minus sin w, because t equal 1. So to apply the bisection method, we have to form a function from the equation after putting t equal 1. We have x of 1, t here equal 1, minus g over 2 w squared multiply sin w, the rational part, minus sin w, because t equal 1. Also, we use the parameter values, g equals 32.17 and x of 1 equal 1.7. Here always w is negative. So we can define the following function: f of w when t equal 1, f of w equal 1.7 plus 31.17 over 2w squared multiply inside the bracket sin w minus sin w. This is the function at which with which we will use the bisection method. It is clear that this function is also continuous everywhere on the real numbers. Now we will assume an interval whose lower bound is b and the upper bound is a here, because we will work on the negative part of real numbers. We will consider the lower part is b and the upper part of the interval is a, without loss of generality. To find the upper and lower bounds of the interval, we will recall the Maclaurin expansion or Maclaurin series of the sin and w and sin w, as shown here. This is the Maclaurin expansion or series of the sin and sin w, which are the quantities inside the bracket of the function f of w. So if we subtract the quantity sin w from the quantity sin w, we will have this form, and divided the difference by w squared, we will have the following Maclaurin, the following expansion or the following series. Now we will substitute this quantity sin w minus sin w over w square into the f of w. We will obtain f of w equal 1.7 plus 31.17 multiply this quantity inside the bracket. Don't forget, our objective is to find the lower bound b and the upper bound a of the intervals. Now to find the lower bound, the upper bound a of the interval b and a, we still remember that w is negative. So if we start is very close to 0 with a negative number very close to 0, which is minus 0.001 or minus 10 power minus 3, we find that f of a is positive, bigger than 0. The reason is that when w starts as w1 very close to 0 in the negative part, all the higher order terms are vanishing. So it remains only the first two terms, 1.7 plus 32.17 multiply w or omega divided by factorial 3, which is 6. So the result is still smaller than 1.7, and the result also is still positive. So we can choose A equals minus 0.001 or minus 10 power minus 3. To find the value B or the lower bound of the interval, we need to ensure that f of b is negative. So we can select w smaller than 0 in the negative part, nearly far from the value a. So the higher order parts may not all of them vanishing, and some of them may be negative. So also we can control the first term in the expansion so that the value of the f of w is positive. Yes, is negative. So we may put the condition 1.7. This is the first term on the right hand side of f of w, plus 32.17 over w of multiply w over factorial 3, which is the first part in the expansion of the expansion inside the bracket. If we put this condition negative, we will ensure that all the f of w is negative. This implies that the value w2 or b, the lower bound of the interval, must be smaller than minus 6 multiply 1.7 over 32.17, which is a direct solution of the last inequality. So b can approximately equal minus 0.3170. Yani we can take any value for b which is lower than this value minus 0.3170. So we can take, for example, b equal minus 0.4. Now we have the following interval B and A. B equal minus 0.4 and A equal minus 10.3, 10 power minus 3. F is continuous and f of A is positive, f of B is negative. So the conditions, all the conditions of the bisection method are hold. So we can use the bisection method. We can apply the bisection method to our function f of W. In this slide also I give another way of guessing the bisection interval using the try and fail method. This can be we can use the help of this graph, the graph of sine x and sine x. In the negative part, we observe that the red graph of sine x is always above the blue graph of sine x. So if we start in a small vicinity of 0 in the negative part, we may try some values of the lower bound of the interval, like minus pi over 4 or minus pi over 2 or minus pi. All these values can be tried as lower bounds of the bisection interval, and we can try the conditions of the bisection method. Now we are going to calculate the number of iterations in. We remember that our upper bound is A and the lower bound is B of the interval, so we will have the condition A minus B over 2n lower than the error or tolerance 10 power minus 5. Solving this interval implies that 2 power minus n multiply A minus B lower than 10 power minus 5. If we take the decimal logarithm for both sides, we will have minus n multiply log 2 for the base 10 lower than minus 5 minus log A minus B for the base 10. Finally, to solve this inequality for n, we multiply both sides by minus and change the inequality sign, so we will have finally n bigger than 5 plus log A minus B for the base 10 divided by log 2 for the base 10. Calculating this inequality, we have n the number of iterations equals 16. So after 16 iterations, we will have the solution for W or omega minus 0.317060. Now I will provide a Matlab code for the solving the last problem. First, we will put the inputs of the bisection algorithm. The inputs is the function and the parameters g, the numerical values of parameter g and x, and the function f of w. Here the variable is w, and the limitations of the interval a, the upper bound minus 0.001 and b is the lower bound, as we have discussed before, minus 0.4. Also, we will put the conditions for the number of iterations. Here n is coded like this using this command, as we have previously explained. N must be bigger than 5 plus log b minus a for the base 10 over log 2 for the base 10. This is the condition we have derived it before, and we will put the ceiling of n small, which is n capital, to obtain the minimum number, the minimum integer n capital is the minimum integer which is not less than n small, the ceiling function. Here is the loop of the bisection method for I starts from 1 to the n, the number of iterations. We will put the midpoint of the interval c equal a plus b over 2. I here we intend to print c for each iteration. The condition here f of c bigger than 0 because f of a is positive. So if f of c bigger than 0, then the a equals c. Otherwise, if f of c lower than 0, then p equals c. And then we end f and end 4, and we request from the code to print the value of ch iterations. Finally, we will request from the code to print the final value as rate of the rate w is the number c. Here, the output of the program will be divided into two columns, one column for the iteration number and one column for the value of c or w. Like this. This is the picture for the first 8 iterations, and another graph for the other iteration till 16 iterations is shown here. Finally, we have the final answer printed in the code as follow. The rate w is minus 0.317060. And thank you very much.